the base is always attached to what? What's the base always attached to? The what? What's the base attached to? Yeah, the exponent. Okay, so this is your base, this is your base, this is your base, this is your base. Okay, so that's what we're going to have to look at. Okay, so this one would be growth because it's 2, it's the absolute value is greater than 1. And you do the absolute value because remember, it can grow in the negative direction. In fact, that's what's happening here. Okay, this is 0.2, it's between 0 and 1, so it's decay. This one is 0.5 between 0 and 1, so that one's decay. This one is above 1, so it's going to be growth. Okay? Alright, so I told you 2 and 4, you could use your calculators. Okay, and I said to make a table with at least 5 values. When you're choosing your values, really just make sure you have enough to generate this curve here. Okay, that you have a curve, and then it should be going towards the line y equals 0, which I have my dashed line there because what is this special line? What's that called? Yeah, the asymptote. Okay, so the y equals 0 is the asymptote. Okay, and then when you are doing this without a calculator, if you're trying to do, for example, like this one, you had -2. So if you have -2 to the -2 power, the rule is you use the reciprocal, and then what happens to the exponent? No, it is negative. Yeah, that exponent becomes positive. Okay, so then that negative still stays out in front, but now this is 1 over 2 squared, which would be -1/4. Okay, so -2 to the -1 means I have my negative in front still, but 2 to the first is just 2, so that's how I'm getting my values. Okay, be careful with the 0 because we know that 2 to the 0 is 1, but again, you have that negative in front, so it should be -1. Okay? Now, if you're not using a calculator, maybe this was given to you because there are certain things we should know, right? What's the point I know on the graph already? Just by looking at the equation? Yeah, what's that? Yeah, it occurs when y is 0, so that's our, yep. So you should know right away. That's your y-intercept, right? And you should know if it's growth or decay. Same thing with this, right? So 4, 0, 4 should be on your graph. Okay, so those are conceptual things that we need to know. All right? Your form is y equals a times b to the x. We talked about a is your initial value or your y-intercept. Okay? All right, what questions do you guys have for me on 1 through 4 here? Got the asymptote, we got the mental math. Got that down? Okay, for every exponential function, every single one is always going to approach what? Yeah, every single one should approach what? Y equals 0. So every single one should be going towards the x-axis at some point. So if yours is like flipping over the x-axis or getting crazy, okay, we know we need to go back and fix it. Okay? Should be a nice curve. Sometimes the curves are more drawn out, just if they're growing slower versus quickly. All right. Now we also have a story problem. So with your story problems, I let you use your graphing calculator to come up with those values. So that's probably not something I'm going to ask you to do without a calculator. What I would know how to do is I would know these models and what all the values mean, right? Because A is going to be the what? What do we call that value? No? The initial value. Good. That's what you start with. So something that you could do without a calculator would be writing the function, right? Okay, Okay, and then if you have, remember part of the quiz is multiple choice. So you could eliminate answers based on, do you know what the initial value is? Do you have the correct decay or growth factor? Okay, because if it's growth, you have to add 1 to the rate, but if it's decay, you have to do 1 minus the rate. And remember, when you write the rate should be written as a what? A decimal. Okay, so maybe like a tricky one would be, instead of 0.85, having 85. So something like that, right, to watch out for. And then you graph the function in part B. Again, there are things we can recognize from the graph, like the initial value is your y-intercept. And then it says, suppose the car was worth $20,000 in 2005. What's the first year that the value of this car will be worth less than half of that value? So I used my graph, okay, drew my line, and I got somewhere between 4 and 5 years, it was exactly 10,000. So if it asks when it will be worth less half of that value, okay, I'm going to have to go up because it's saying less than that. If you used your graphing calculator, the intersect feature, you got 4.3. Again, 4.3 is when it is worth 10,000, and then we wouldn't say like 2009.3 years, right? So that's why we're rounding up to the 2010. Okay, so what's the first year the value of the car would be worth less half? It would be 2010. Okay. All right, so again, we got to know the growth model, and we got to know the decay model. We have to understand what those values are, and we have to use logic. Now, when I say that, I mean, maybe it'll say, oh, find the value of the car in 2020. Find the value of that car in 2020. And maybe one of the possible answers is 30,000. Now, why do we know that that's not possible? Because it's going down, right? So you can use logic to solve when it's multiple choice, right? If it was a growth model and they gave you a value that was less than the initial, you could eliminate that right away. Okay, so there will be like logical questions that you can answer without a calculator, and you can use the process of elimination. All right, any questions for me about the story problem, growth model? All right, let's go to page 2.